We are going to be introducing these topics. Find the area bounded by h of x equals 2 plus sine of x and the x-axis on the closed interval from negative 3 pi over 2 to pi using the left Riemann sum with 5 subintervals. Okay, so we're using the equation area equals base times height. So first, to find the height, we have to do b minus a over n being the number of subintervals, and b and a being the closed interval from a to b. So plugging in these values, you get pi over 2. Pi over 2 is the height, and this is your interval. So figuring out your different height values, you plug them into the equation and get your base values. So when you plug your height values and your base or your height, which is pi over 2, and your base values into the equation and add them up, you get 11 pi over 2. But notice, since we're using the left Riemann sum, you do not use the last value. Okay, find the area bounded by h of x equals 2 plus sine of x and the x-axis on the closed interval from negative 3 pi over 2 to pi using the right Riemann sum of 5 subintervals. And the height is still the same from when we used the left Riemann sum, and so are all the values. So here's the height and here's all the values. Something to remember when using the right Riemann sum is you never use the first value. So we're still using a equals base times height, and the height is still pi over 2. So instead of starting with 3 and going down to this 3, we start at 2 and go all the way down to this 2. So when you solve that whole equation, you get 12 pi over 2, which is 6 pi. Find the area bounded by h of x equals 2 plus sine of x and the x-axis on the closed interval from negative 3 pi over 2 to pi using the trapezoidal rule with 5 subintervals. And the height is still the same, and so are the values. So the equation to find the area of the trapezoid is 1/2 height times the sum of the bases. Find the area bounded by h of x equals 2 plus sine of x and the x-axis on the closed interval from negative 3 pi over 2 to pi using the midpoint of rectangles with 5 subintervals. So the height equals pi over 2 is the same, and all of these values are the same from the previous problem. Area equals base times height is still what we're using, but first we must find the base, which, since we're using the midpoint, we have to find the midpoint of the base. So the midpoint equals the value to the left plus the value to the right all over 2. So this is the first one. Negative 3 pi over 2 plus negative pi all over 2 equals negative 5 pi over 4. Once you find this value, you must plug it into the h of x formula, and then you get 2 plus root 2 over 2. You do this with every value to find the midpoint of each base, and you plug it into the h of x formula. And once you have all your bases, you still use the area equals base times height. So since height is pi over 2, you have pi over 2 times all of your bases that you found. Once you solve this, you get 5 pi root 2 all over 2. After you find the area of each of the rectangles and add them up, you get 21 pi over 4. Notice that the first and last values are only used once while the others are used twice.
For the left Riemann sum, the graph is right here and the points are given to you, and if you see the left corner is given in the rectangle, like that's the point where you're supposed to start doing the rectangles. And this is the base and this is the height. And to find the area bounded by the graph and the x-axis on the closed interval from 0 to 2 using the left Riemann sum with 4 subintervals, and you still use the area equals base times height, and 1/2 is the height and base 2, and you just keep adding the height times the base to get 157 over 32.
Find the area bounded by the graph and the x-axis on the closed interval from 0 to 2 using the right Riemann sum with 4 subintervals. This is the graph and the points are given to you. And with the right Riemann sum, the top right corner of the rectangle is touching the graph. The equation is area equals base times height, and the height is still 1/2, and the base changes with each rectangle. So you add up the area of each of the rectangles, and you get 41/4. Find the area bounded by the graph in the x-axis on the closed interval from 0 to 2 using the midpoint of rectangles with 4 subintervals. This is the graph of f of x, this red line right here, and these are the plotted points, the red dots. Okay, we are using area equals base times height. To find height, it's h equals b minus a over n, which equals 2 minus 0/4, which equals 1/2. B minus a comes from the closed interval from a to b, so that's where that comes from. And then to find the base, we have m1 equals L1 plus R1/2, which means you have to find the midpoint, because that's what we're using, and you take the left value plus the right value all over 2. So m1 is done for you. You have 1/2 plus 0/2 equals 1/4. You do all of these as well. But sometimes you may not have to find your base if you are given your midpoints already, which in this case you are, because if you look at the graph, you can't just tell what the y value would be for 1/4 right here, so you have to be given this information. So you have area equals base times height, so area equals the height, which is 1/2, which we found, and then you have to add up all of your bases together and multiply them by 1/2. Once you do that, you get 63/. Find the area bounded by the graph in the x-axis on the closed interval from 0 to 2 using the trapezoidal rule with 4 subintervals. Here's the graph, and to draw the trapezoids, all you do is you just draw a trapezoid from all of your heights, all your subintervals. So the points are given to you again, and the area is still, for trapezoids, 1/2 the height times the sum of the bases. So starting with the first trapezoid, 1/2 times the height, which is still 1/2, times the sum of the bases, which is 2 plus 17/8, which is the same for all of these with their different base values. And if you solve this equation, it comes to 33/. Sometimes on FRQ questions, you are asked if this example was an understatement or an overstatement. Well, this is how you can tell. If the graph is concave up, such as these two are, then it is always an understatement. When it is concave down, it is an overstatement. If you need any more help, there's links down below. Thanks for watching.